This is EE542 demonstration for lab 1 computer networking. So before we start, I would love to give you a brief introduction about the lab requirement. So the main idea of this lab is to connect into the computer network by using two Linux machines, which basically is just building a client-server model to establish communications between two Linux machines. Next, I will explain what is the functions for both client and server. So this model mechanism is shown in the figure. So at the beginning, the server will start and create the socket used for listening, and then clients will sending connecting requests to the server. Once the server receives the request, it will process it and then sending a reply back to the client. And after that, the connection will be established between the client and server. And this will continue until the client terminates the connection. And for the server side, it will either close the connection or wait for another new client connections. And then I will have some part of our code being explained, which are the important code parts. The first part is both two servers need to create sockets to listen coming connections. The socket is interfaces to communicate in the network. So the socket system call creates new socket, and it takes three arguments. The first is the address domain of the socket. There are two possible address domains: the Unix domain for two processes which share the common file system, and the Internet domain for any two hosts on the Internet. The f Unix is used for the former, and the f Internet is for the latter. The second argument is the type of the socket. There are two choices. The symbolic constant are socket string and socket diagram, so which are used for the TCP and UDP accordingly. The third argument is the protocol. If this argument is 0, the operating system will choose the most appropriate protocol automatically. The socket system call returns an entry into a file descriptor table. This value is used for all subsequent references to this socket. We need to fill out the server address, which is a structure of type struct socket address in. It is building block for creating socket and has 4 fields. The first field is a short SIM family. The second field is the server address is unsigned short SIM port, which contains the port number passed as an argument. The third field contains the IP address of the host, which must be in network byte order. And then we can see the bind system call binds a socket to an address. In this case, the address of the current host and port number on which the server will run. And next one is a listen system call, which allows the process to listen on the socket for connections. The first argument is a socket file descriptor, and the second is the size of the backlog queue. So basically it is the number of the connections that can be awaiting while the process is handling the particular connections. The next part of our important code is multiprocessing. The fork is a system call function which can generate child process from parent main process. So basically we are creating a child socket for data transmission. So after a new child process is created, both processes will execute the next instruction following the fork system call. Therefore, we have to distinguish the parent from the child by getting its return value. The negative value means failure, while 0 means success, and positive value is the process ID of the child process to the parent. In the child process, the server could communicate with different clients. The third part of our important code is the multi-threading. So a single process can contain multiple threads. So in this laboratory, we create several threads in our code. And those threads share the same global memory, but each thread has its own stack. So basically, in the function, the server can send and receive messages through the threads. The final part of our code is the killing zombie process. So first of all, what is a zombie? If a parent runs for a long time and accepts many connections, each of these connections will create a zombie when the connection is terminated. A zombie is a process which is terminated but cannot be permitted to fully die because at some point in the future, the parent of the process might execute a wait and we want information about the death of the child. So in our code, we use signal action to rip zombie process so that we wouldn't have a lot of zombies in our system. And then I would love to talk about the result. So the first part of our result is that we need to get the IP address of the server so that the client know who to connect. So as shown in the figure, we have obtained the IP address of the server, which is 10.2.47.245. And then the result for the server, as shown in the figure, we can see there are 3 different clients connecting to the server. So after the connection being established between them, there are data communications between the server and client, and all of the information such as IP address, port numbers can be obtained. And for the client side, we also can see from the pictures that whenever we are sending messages from the client to the server, we can get the reply from the server. So which also means the connections and communications are being established successfully. And after the client send end instruction, the connection will be terminated. And there are a few essential points that I want to stress in our laboratory. The first one is that why we need multiprocessing and multithreading and how it differ from each other. So in original lab, only one client can be connected to the server, which is not practical because in real life there would be multiple clients want to establish the connection to the server at the same time. So we use multiprocessing and threading at this point. And the reason why we need multiprocessing more generally is as following. First of all is time sharing. Second is there might be different applications per user or several processes per application. And the final reason is to have the concurrent computing. And comparing with multithreading, the multiprocessing is adding more number of CPUs or processors to increase computing speed of the system. But multithreading is allowing a process to create more threads which increase the responsiveness of the system. So this is the differences between multiprocessing and multithreading. The second point I want to stress is that how to find the IP address from a host name in our laboratory. So in real life, the IP address of a server is fixed and the client host could find their IP address through its host name. For example, that we can find the IP address of Google from just typing the name of the google.com. But in our case, server IP address is dynamic, assigned by the routing using DHCP. So since our server doesn't register DNS domain, we cannot get IP from DNS service. If we add a line which matches IP address with host name in the host file, it will work in a specific case, but it won't work in other cases. So now we're gonna demonstrate how the program exactly gonna work. So the first step, we're gonna start the server with the port number 34567, which is a big display screen. Okay, now we're gonna use the 2 clients. We open 2 processes to connect it to the server. So we see both of them are connecting to the server successfully. And then we're gonna send messages. Let's see if it works. So let's send hello for the both side. Okay, we see from the client window that we received a message from the client that I got your message, and at the server side we accept hello from the client. And then let's try another message. You see, we also get a reply from the client, which suggests that the connection is being built successfully. And at the server side, we also received the message from the client. And now we're gonna enter the end instruction from the client side to end the connection. And we can see from the display that client closed successfully for the both client. Now we are going to use multi-threading to see if we can get the same answer. So the first server we use multiprocessing. Now we build server 2 with the port number 45678. Let's see if we got the same successful connection between client and server. Now we can see the connection being between client and server are built successfully. And let's send a message, hello. And we see the server already accept the message. And we try another message. And we got the same successful answer. And now we're putting end instruction. Now the connection is being closed. Thank you for your listening.